Hi, and welcome to the first CDS Engineering video update. My name is Stuart Lowe and I'm leading the engineering working group within the Consumer Data Standards team. Firstly, a quick recap for those who just joined us. The Consumer Data Right is an Australian government initiative to allow consumers to access and safely transfer their data from organisations they currently have relationships with to organisations offering value-added services they wish to establish a relationship with. These are referred to as data holders and data recipients. All data sharing occurs through consumer consent on a scope and time-limited basis. While banking is the initial focus sector, the intention is to expand this further into energy and telecommunications. To implement this, the Treasury is establishing a legislative instrument that designates the Australian Competition and Consumer Commission as the lead regulator. In order to enable the technology components of this instrument, the interim data standards body has been created to establish the technical standards under which the consumer data right will exist. The data standards body is comprised of an advisory committee chaired by Andrew Stevens and Data 61, who act as technical advisory within the data standards body. There are a number of work streams, including the standards work stream, which sets the overall technical definition for the CDR, the CX workstream, which guides the customer and user experience elements of the CDR, information security, which defines the security landscape for CDR, and engineering, which this presentation focuses on. Specifically on engineering, our role is threefold. First, to validate the emerging standards through demonstrable software artifacts. Secondly, to produce a proof of concept demonstrating a simulation of the CDR ecosystem. And finally, by proxy, to act as a coal mine canary regarding technical implementation challenges. All of this is driven by an overall goal of delivering software that is useful to participants within the emerging CDR ecosystem. To understand how engineering is structuring delivery of this simulation, we have defined a number of artifacts. The supporting documentation provides a written definition of a variety of areas regarding how the CDR will operate. From these, the CDS engineering team is focused on delivering a number of software artifacts, including a Java-based client library or reference implementation, which can be integrated into a potential data recipient's codebase, an associated CLI to allow developers to interact with the standards APIs during development, a test harness, which provides automated testing of a target API, and a command line validator to allow holders to test and revise sample payloads. In addition to these client-side components, the engineering team is also developing a set of server-side components comprised of a Java definition of server stubs, which show developers and provide them with a starting point for development of compliant APIs, a demonstration of the information security profile through a sample authentication and authorization implementation, a model holder, which, using synthetic data, provides a demonstration of the data holder role within the CDR, and finally, a self-contained demonstration of the registry, and more details around this will come as they're developed. Finally, in order to make these outputs a reality, engineering has produced a number of supporting artifacts to programmatically describe through the CDS models and generate through CDS CodeGen these outputs from the emerging standards. And so, to try and explain where engineering is so far, we thought it would be good to provide some initial demos of some of our progress so far. Today, I'm going to focus on the product API's functionality, as this is intended to be the first deliverable from the Big Four banks. I'll be showing a model holder with recipient CLI, a model holder with conformance, and the supporting artifacts that enable these components. Firstly, a demo holder which uses a CDS client library and the client CLI to consume the product API. Right now, this is a Spring-based web service that allows payloads to be customized and presented from a sample data holder. The associated client and client CLI are generated using the CDS CodeGen generator, and payloads are loaded on startup. Just a quick note that we have made these available as Docker containers on Docker Hub, which you can find here. So the first thing I'm going to do is I'm going to start the holder, get that up and running. And as I said before, that's all available via Docker Hub. So we'll just set up a Docker run command here, and this is binding to port 8080 for now. And on startup, what it will do is it'll actually go and load a sample payload, and you can grow these payloads out just by putting them in the directory. So that looks like it's started now. And then from another screen representing this client side in this diagram, we'll start running, once again from a Docker container, the CDS client Java CLI. Now the client Java CLI is a Spring Boot shell, and you can do a help command, and you can see it has a number of built-in commands, but also it's got these common functions for setting the server endpoint, and initially the product APIs. So I'm just going to set the server here so that it knows where to reach out to. Eventually this will actually be probably supplemented using the discovery interface from the registry. Looks all right. And so from this here, I can now do a list products. You can see that it accessed over here, and we received our product list, a brief product list. And then from here, and using this product ID that's been output, right, I can do get product detail here. And now I get the detailed information as per the standards API. So that's the CLI and holder for product APIs. Next, what we're going to do is we're going to take a look at an early release of the conformance tools. And so this particular part is focused on an initial test harness, as I mentioned before, to test against a live API, and a CLI that can load and validate JSON files. We expect conformance will evolve over time, so this is mainly focused on a quick tech preview of validating the product API using the same holder that we've already used. So just going through here. Still have this model holder running here. And now we'll just load up the conformance. Now this is currently just under support samples in CDS CodeGen, but we'll split this out into its own repo pretty soon, possibly this week. So the first things we can do is we can run Maven clean package. Now, right now this will assume localhost 8080, and as part of the tests here, what we can see is that it's gone and done a number of tests, but it's also accessed this model holder and proceeded to verify it. So from an integration test standpoint, we're running our integration test quite effectively here. You can see it's got quite a little bit of output. We've had a successful test run here. In addition to that, and we are looking at actually merging this in to the client CLI, is the conformance suite also has its own CLI. And so that's really focused on being able to take in some static JSON files and being able to validate them offline. So you don't need an API to be online. Okay, you can just supply a JSON file of literally any payload that you're talking about. Okay, and what it will do is it'll identify the model that it's matched to, and also what function this type of embedded data comes from. In this particular case, the banking account deposit rate is actually part of the get account detail. Now, I should have iterated that this is an alpha release, so the conformance suite has a lot of work left to do on it, but we're just trying to show you what the general flow of things is, and we'll keep you up to date as that becomes more mature. Now, the final part, of course, is the CDS CodeGen. And CDS CodeGen, the intention, as we communicated before, is really to provide a way of outputting these artifacts quickly and efficiently. We wanted to avoid a situation where we're doing heavy amounts of hand management as each of these artifacts grew. And so instead we developed a CodeGen or a template engine with a Java models definition. That means we can fully describe all of these interactions and then dynamically generate the code. Now, at the moment, we're just generating the client library and the client CLI, but we do intend to expand that out further over time. What we have right now is we have a representation of the standards in the Java reflections. It is also directly attached to Swagger Core, native Swagger Core, so we can generate a very rich Swagger 2.0 specification in native format. And also a code generator, as I mentioned, using velocity templates and a JSON configuration. Now, what we haven't done yet is keep it well documented, and so that's really a plan for this sprint. We are still needing to keep it up to date with the latest standards. Obviously, that's a work in progress as the approval processes go through with James, and so yeah, we will realign there, and we're not quite there yet as far as product APIs, but also beyond product APIs, we're still very much a work in progress. We have been focused on the product APIs because of that initial deliverable and sort of getting down that groundwork, so to speak, up. So, and finally, we're working on data operation modeling support. So that's where a list command relates to a get command. How do we show that or describe that in models so that we can automatically generate code from that? But anyway, I digress. So as a quick demonstration, we're going to be focused on these parts here. We'll just load up CDS CodeGen Core. And so we are doing this from source. There is some Docker containers out there, but to be honest, if you're digging into this right now, you're probably better to check the source out and build from Maven. So we can just do that. Maven clean package here. You can see it's also building that Docker container I mentioned. So that sort of comes out of the box. It's output some Java doc as well. So we've now built that package, and that has its own command line. Now by default, the command line, as you can see here, the generator in focused is Swagger generator, and so that'll just output straight to std out. And if I just run this here, this native. And in this case, I'm also filtering it just on the products API. We want to, you can specify multiple comma separated sections, but this way you can pick and choose which sections you're generating for. So we can see here that we get a Swagger 2.0 specification. It has all of the parts from the standards, as well as a rich set of things like regular expressions, a little bit of extra metadata in there when it comes to reading. So that's the generation part. And then with relation to code generator, as I mentioned, it's a JSON configured and velocity powered, velocity template powered generator. We will provide more documentation on this so that you can look at building your own code generation templates. So here we go. Here we're just going to generate the client Java library into this directory, and we're going to filter on products API. Okay, and we can see it outputs all the files along with the models and literally everything associated with the standards in a compilable format straight away. So that's the overall CDS CodeGen. I think we'll probably leave it there. I hope this has been enjoyable. You've enjoyed the run through. Feel free to sign up to the mailing list or follow the engineering blog, and I will provide more updates soon. Thank you.